This film records the manufacturing process of Timken Alloy Steel Europe Limited, formerly known as the TI Eagle Works. The factory began as Tubes Limited during the 1940s, supplying coal-drawn steel tubes for the Ministry of Defence. It expanded over the years to a 36-acre site with hot rolling, finishing and cold reducing departments. The hot rolled process was introduced by Tube Investments Limited in 1954 to meet the growing needs of bearing manufacturers. It uses the Acel process developed by the Timken Company in the USA, who became the eventual owners of the Desford site. The factory ceased production in 2007. This short film shows the process of rolling and finishing hot-rolled seamless tubes. The raw material for tube making can be seen here. Round steel bars in a wide variety of specifications, with diameters between 76 and 220 millimetres. This is delivered by road from UK and European steel mills. The first operation is to mark the bars into shorter lengths called billets. Lengths are calculated to give the best material yield, and the bars are then fed through to the billet cutting section. There are two options for cutting, depending on the type of steel. They can be cut using an acetylene burner, aided by an injection of iron powder, or they can be cut by a carbide saw, as seen here. The conveyor then transfers the billets for each order to the rotary hearth furnace. This furnace was supplied by the Salem Engineering Company and has a diameter of 13.7 metres. The rotating hearth is 3.5 metres wide and runs in a water trough to seal the combustion chamber. Billets are loaded by a hydraulic arm called the charge peel. Timed gaps are left between each billet, allowing up to 160 to be heated in the furnace at any one time. The furnace is heated by a combination of natural gas and preheated air. A heat exchanger under the floor uses the hot waste gas to bring the temperature of ingoing air up to around 450 degrees Celsius. The furnace is divided into 4 zones with individual temperature settings. These are computer controlled to bring the billets up to rolling temperature, which is usually 1130 or 1250 degrees Celsius. The discharge peel takes billets from the furnace at a timed rate and drops them to a conveyor which carries them to the centre press. In the centre press, the end of the billet is dimpled by a pneumatic ram. This helps to start the next operation, which is the piercing mill. The billet rolls down to the inlet of the piercer, where a hydraulic ram pushes it into the piercer roll. The 2 barrel-shaped rolls of this mill are inclined at an angle to feed the billet into the mill. They are driven by a 2,000 horsepower DC motor, geared down to give a roll speed of around 150 revs per minute. The stresses created in the centre of the billet allow it to be fed over a conical steel plug, which is positioned at a critical point between the two rolls. This creates a tubular shell known as a bloom.